Cool. Just a quick recap. What we talk about on Monday. Um, we talk about the classes about AI and music, but to view it properly, usually I tend to view it as, how music and technology co-evolves over time. And that will sort of become the framework how we should look at AI is that, there are inference. It's like bi-directional inference between music and AI. It's not like AI just providing a bunch of tools for music, but on the other hand, on day one, since the start of AI, people are very interested in looking into whether AI can compose music. And yet, after 50 years, people are still looking into it. There are always challenges that inspire some of the technology evolution. But at the same time, these technology also enable new musical interfaces, opportunities, instruments, all sort of different ways to express yourself through music. Um, and we look at some of the more positive examples than some of the news you might have heard of on the on blogs, you know you I don't know, YouTube, TikTok, whatever, tend to be negative most of the time, for some reason. But there are also many very interesting venues where people are using AI in a positive way, to enable new opportunity, but also to improve accessibility on stage or for music creation. And then we talk about, how fast this field evolves. And that sort of will be the theme of this class is that, even after just taking this class at the end of the in December, things will change quite a lot. Often that's the case. This is like in June 2023, and people are still looking at, this very stock music like, and this is sort of the first big model for text to music generation. But nowadays, we have Suno, we have, Music FX, all sort of different big companies are investing into seeing what we can do with these text to music generator. But this is not the full story, but this is just what people tend to refer to, tend to think about when people talk about AI for music. But in the class, we will also talk about a lot of other perspective rather than just music creation with single bottom. There are all sort of different ways that you can interact with this these technology, but at the same time, production, recommendation, retrieval, analysis, transcription, optical music recognition, downbeat tracking, source separation, all sort of like different technology are used in the music industry and in music creation. And last time we end up at this music FX DJ. Have you played with it? Definitely take a look. I think it's one of a kind. It's very cool because you can think about, sort of like future ways of I don't know, mixing music or not mixing music, more like, DJing for music. Think about, I was recently discussing a new research project about this. It's like, think about a game environment, say Minecraft or, say like an open world RGB RPG game where you just walk around a free space. And then, typically when you switch the map or you go into another zone, the music will just cross over to another zone. But think about Music FX DJ. Could we sort of like imagine a new kinds of gaming experience where the music just slowly, smoothly transform to another song rather than, pre-compose and then just like cross over that? Can we do a very smooth transition between the boundary of maps so that these maps don't have a hard boundary? It's more like you just enter a new world. These are the way they release it, but there are so many interesting direction that you can approach it to do it more fun. Cool. So today we will talk about some of the technical background like AI and ML fundamentals. We will just layer by layer go more into the details as long as along the way we progress through some of the more technical aspect of that. Um, cool. So we will talk about some of the AI and machine learning fundamentals. It will be a little bit philosophical today, but I guess that's also part of the discussion of what AI is. Oh no, let me see. I put everything on cloud, so that's the risk. Uh, let me see. Cool, 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 cool. Cool. Get rid of this. Cool. So today I would just want to talk about, very scratching the surface of AI and machine learning. And that's sort of like different from what we know about AI. Mostly what people have been talking about recently is about deep learning, of course. But AI and machine learning is a much broader field, where it has long history and also long history with music. So I guess we would just start from discussing what is artificial intelligence. Um, so I always like this thing, this clip. The sound. Hmm.
Murder's a new trick for a robot. Congratulations. Respond.
What does this action signify? As you entered, when you looked at the other human, what does it mean?
It's a sign of trust. It's a human thing. You wouldn't understand.
My father tried to teach me human emotions. They are difficult.
You mean you're a designer?
Yes.
So why'd you murder him?
I did not murder Dr. Lanning.
Want to explain why you were hiding at the crime scene?
I was frightened.
Robots don't feel fear. They don't feel anything. They don't get hungry. They don't sleep.
I do. I have even had dreams.
Human beings have dreams. Even dogs have dreams, but not you. You are just a machine. An imitation of life. Can a robot write a symphony? Can a robot turn a canvas into a beautiful masterpiece?
Can you?
Um, have you seen it? Me? No. I mean, I mean, I just follow all the AI stuff on Twitter, and oftentimes this just come up. So I guess that's sort of give you the hint of what AI is. It's like oftentimes we are sort of like asking AI too much that we human couldn't do. So sometimes, it's funny to look at that. It's like, well, some of the AI thing you can think of, you can do better than them. But at the same time, we are sort of like asking AI to be capable of everything. That doesn't, really make sense if we are thinking about what AI is. If AI is to be an imitation of human, then um, we human has our limitations. So what is AI? So I guess there are some, technical definition, but this is one of the definition that I like reading. I like very much. So I think that's more accurate than some of the others. So AI is the study of how to make computers do things at which, at the moment, people are better. So this sort of hints you a little bit about the history of AI. Chess is one of the things that people thought of as the grand challenge of AI. So AI sort of like started at 1930, 20-ish. And then in 1950, that's when all the AI started to get formulated. But only until 1997, that's the first time. This is the IBM Deep Blue. So they are running a system that's, running that some, algorithm on the supercomputer. So IBM Deep Blue is the then supercomputer, the best supercomputer in the world. And they beat the, world champion in chess in 1997. And then people are like, well, chess is no longer the AI grand challenge. So people look into, Go. Likely, this AlphaGo in 2016. Then, there's this AI developed by Google DeepMind, which is called AlphaGo. And, recently there's also like AlphaFold. So Alpha something usually are products from Google DeepMind. But, at the time, now Go was beaten by some AI. So now people are even looking into, can we do better in this is called StarCraft, right? Is it? I guess, have you played that? No, StarCraft, right? Yeah. So yeah, I mean, there's also a team in DeepMind. They are trying very hard to let the the machine to play StarCraft, and they are still in progress. I mean, I think at some point it's like 30% winning rate, and hopefully to 50%, and at some point 70%. So, going from, strategic game from chess, a much smaller decision space, to Go, a much larger decision space. And now we are even looking into, StarCraft, where, human can oftentimes be very struggling in, managing the whole decision space. So, I think this definition of AI is very interesting because it sort of like reflects our own feeling of what AI is. And, we always want more from AI with the development of AI. But, more strictly speaking, there are also different ways of defining AI. So some people think that system that has to think like humans, then we can code it AI. But also people also define AI as, system that act like humans. But also, it's not just about like humans. It's not just about human like. Sometimes you need to think rationally rather than just thinking like humans, because, humans could be thinking irrationally, but at the same time, system that act rationally. So we will talk a little bit about, different types of AI so that you get a sense what's the landscape of AI when we talk about what is AI. So, thinking versus acting. So this is a very interesting example of AI, when people talk about discussing AI. And, this is the Turk. It's like 1770. So this is a very interesting chess playing AI. They claim it to be AI, but it's a very interesting So basically, they are claiming that this is the then AI, where they actually beaten claim that it beaten some of the then world champion in chess. So in fact, it's actually not magic. So this is like the inner working of that machine. To give you
This is the
what's actually
Turk,
going
a
on.
mechanical chess-playing robot from the 1700s that was basically unbeatable. It made its own moves, called checkmate, and even laughed in its opponent.
Let me see. I think I have the right time.
This is the Turk, a
Nope. Well, I thought I have the timing somewhere here. Oops, here.
As it turned out, the Turk wasn't automated at all, and was, in fact, operated by a chess master hidden inside the machine at all times. The fake machinery and the bottom drawer didn't extend all the way to the back of the cabinet, and so there was space for the operator to sit with his legs stretched out under a fake floor. Before the left door was opened, the operator would slide forward on a movable chair into the main compartment, closing behind him a secret door. The presenter would then open the rear door and show the audience that there was nothing but machinery inside. As the presenter closed the rear door, the operator would slide back into his original position, closing another door behind him and in front of him. The presenter would then open up the front and rear doors to the main compartment to allow the audience to see inside. Having seen right through the whole machine, the audience would now have full belief that no one could be hidden inside the machine. The doors were then locked, and the Turk was ready to come to life. The operator would slide back into the main compartment and open a hidden door inside the Turk's body, revealing a candle, a chessboard, and a mechanical lever which would control the Turk's arm. The lever was in fact a clever pantograph mechanism, using strings that would mimic the exact movements of the Turk's arm. It had a pointer, which the operator could lift to raise the arm and twist to close the Turk's fingers. By moving the pointer over the chessboard, it would move the Turk's hand over the exact same square on the real chessboard. But how did the operator see the moves his opponent was making? Above the operator was a fake ceiling that could be taken down to reveal the bottom of the real chessboard. Under each square was a small magnet dangling from a copper wire. The chess pieces themselves also had magnets in their base, and so the magnets would get pulled up wherever there was a chess piece. As his opponent picked up a chess piece, the corresponding magnet would drop and wobble for about 30 seconds, allowing the operator to see what piece had moved and replicate it on his own chessboard.
Anyway, in 1770, there's no way that, there's the real AI thing. But this sort of like let us rethink about what AI is. So this brings us to the first, distinction between how people think about AI, thinking versus acting, which is more important for AI. So this is the famous, you will see it all the time on news, like Turing test. So Turing test is a very interesting way to think about AI, is that it's more about acting than thinking. So we're interested about the behavior of AI rather than the inner working of AI. And that's sort of, what we know about deep learning today. So deep learning always being criticized as, the black box models where, it's acting like human, but it doesn't actually think like human. And can we trust them? Are they AI? So these are the discussion that people have been thinking about for years. So Turing test is a very interesting way to sort of determine whether this is a good enough AI. And this has been still being used in lots of AI research because there's literally not many ways that we can evaluate an AI system against human. So Turing test is one of the way. So the setup is like this. You have a human being. It could be expert, it could also be novice, depends on what you are claiming your Turing test is trying to do. Do you want to be the general, an average person, or you want to be an expert? But anyway, they will be in two separate rooms, and there will be an interrogator. So the observer, the examiner. They will be asking questions to both the human and the AI system. And so, you will also get response from the human and the AI system. And so the original Turing test, when it was developed by Alan Turing, it's only text-based because that's the easiest way then. But nowadays, think about, when we are evaluating some of the music generation model, we are also doing in other communication channel. But basically, these communication channels should be usable for both human and AI, so that the interrogator couldn't tell from just looking at the format of the communication. So basically we are asking this question: can they tell which is an AI, which is a human? So this is Turing test, and it's very interesting because in last semester there's actually a group of in our class doing this final project, like doing Turing tests for AI mastering algorithm. And somehow, they figured out that, by doing this like blind A/B test, like in the semi-Turing test setup, human couldn't actually tell which one is, mastered by AI, which one is mastered by a computer. So, that sort of suggests that, for AI mastering, does it pass Turing test? At least for some of the easier songs and for average people who doesn't have, much music training. But anyway, they have to judge by the response to the written questions only. So that's the original setup. So this is sort of the way how people can define AI by, observing the outcomes rather than the inner working. But in contrast of this, there's another, this is called the Chinese room. This is the thought experiment when people are discussing what is AI, what do we mean by AI? And this is the way how they think about it in 1980. So imagine we have this like black box room, just like what we have like currently, like ChatGPT. Think about it like a ChatGPT. So we can talk to this this thing, and so you will say something, say in Chinese, you say something to this system, and the system will send to an AI, some sort of like machine that will look up a dictionary and figure out a way that could perfectly respond and send it back to the output. So you will say, do you speak Chinese? And you will say something in Chinese. Yep, I speak fluent Chinese. And then do you know what AI is? And then it will respond, I don't know, what is AI? So, it act like it's very fluent, communication between the system and you. But is this considered, intelligence? Because it acts like an AI system, but the inner working is just doing a bunch of, dictionary lookup. And, the system is just doing this dictionary lookup, and it doesn't have real intelligence, just that it pretends to be very, written in, talking in Chinese very fluent, rather than actually understand what those words mean. So, someone blamed some of the current, ChatGPT to have this kind of behavior where ChatGPT could talk to you in a lot of different languages or different things. But does the model actually understanding, do they actually understand the underlying meaning of those words, or is just doing some statistical distribution matching that, well, this is the most likely words to output, rather than this is the model actually understanding the working of the world? Who knows? So, if you're the AI companies, usually claim that these models know. But as researchers, typically, we don't believe that, some of these models are actually understanding how the working of world. So there are also, recent research direction looking into, what we call war model or common sense. Because sometimes if you look at these ChatGPT models in the early time, even it trained on millions of data. sometimes you ask like very, very simple questions like, how can we, open a water bottle and then pour water into a cup? And there will be WikiHow, like the very interesting wake page that someone will show how to do it. But most of the time, people won't say something like that on Reddit. So that's the training data of how these ChatGPT models are trained on. And it doesn't show whether the model actually understanding what a water bottle means. What do you mean by pour into a cup? So some of these common sense are actually missing in these, big LLM models. So that brings us to the discussion again on, thinking versus acting. Some of these models are acting like a human doesn't mean that they are essentially thinking like a human. And like the distinction is that if you swap these the two components inside this Chinese room, that there will be someone, a human, actually looking at a dictionary or a translator to do all the thinking process, and then have a machine just to write it down and then output it. And it sort of like turn it into the Turk. The actual thinking is happening in the human brain rather than the machine. The machine is just the output of that. So in this case, even though it act like an AI, it doesn't have the thinking process. So this is the discussion that has been years, and people don't really have a consensus on whether thinking and acting is more important. But on the application side, people are more interested in AI that's useful. So most of the time, people are looking into the acting part. Any other aspect of AI is human versus AI. One of the most interesting thing I found over the time when I'm doing AI research is that usually the most helpful AI tool is not that human-like. Because if you can do it, why would you want to use an AI? So most of the time we are interested in more something that's much harder to do with with human brains. So think about like Google search. Why people use Google search? It's because there's just way too many information that you couldn't find it. So it's not AI, but nowadays it becomes more AI. But in the past it's just doing retrieval, doing statistical computation. So that's the things that humans are not so good at, but AI could somehow do it better. So just like this example, and people have been talking about this for years, weak AI versus strong AI. But in the context of music, I don't think we are that interested in this. But to sort of give you the sense that how bad current AI is, so don't be fooled by some of the companies' claim. So when we define weak AI, we are meaning these models are performs a single task, cannot learn from experience, cannot reason. But people are always looking into better way. That's what we call AGI, like artificial general intelligence. So you want to reach human level intelligence. Who knows what it means? But at least they have a self-aware consciousness and solve multiple tasks and can learn and plan over the time. And I guess this is more interesting. People have been proposing so many interesting AGI tests over the time. And so there are like the coffee test. Can the AI make a cup of coffee after entering an average home? You have to find a coffee machine, coffee, add water, blah, blah, blah. So current AI still couldn't do it. Robot college student test. Can AI enroll in a university, take classes like humans and earn its degree? There's also IKEA task. I like this. Can the AI control robot to assemble an IKEA furniture just by reading the instructions? And even more like a business setup. Can AI learn to earn money, invest? So all sort of this sort of like bring us to the discussion of what we actually mean by AI. Does AI need to be human-like? It's not necessary that AI need to be human-like. So I guess that's sort of like give you a little bit about the different ways how people look at AI and some of the current AI application, how we can look at it in in a more structural way, rather than, just using AI as an umbrella term for anything that's just beyond our understanding. So, system that think like humans versus system that act like humans, but also system that think rationally versus, system that act rationally. So on one side, it's like, it has to be human-like. On the other side, it doesn't have to be human-like. It just need to be useful. It just has to be, thinking and acting rationally. So we will be doing this. What do you think? And we will check at the end of the semester. Do you think AI needs to know how to think, or AI doesn't need to know how to think?
It might not be that. I think it's okay for like insights and not like map exactly to what a human would be.
Yeah.
But it doesn't need to think.
Mm-hmm. And it's also terrifying if it think like human. So that's, yeah. Yeah, I'm also more in the, doesn't need to know how to think. And I guess it's also like, I don't know, survival strat. So what do you think? It needs to? It doesn't need to. How about you? It doesn't need to. Okay. The same as we have in the last class. I think everybody just say, yeah, it doesn't need to be that. Okay, we are more. How about the human versus AI perspective? Do they need to be like a human, behave like a human, or it just doesn't need to behave like a human?
I don't think
Nope.
I mean, I guess it would depend on like in the particular field it's being used in. For example, I don't know, like I guess it's not like completely out of topic, but you're using AI to do therapy, for example. Then I guess you would need something that's more relatable, and like a person who's revealing their feelings or whatever would want to speak to someone that's more relatable. I think in the general case, I think it's more of an assistant. And if it behaves like a human, it could even be misleading at some point.
Yeah, definitely. But you mentioned that, in the, medical aspect, oftentimes people are very reluctant to use AI, not because they are, sometimes they even have like better accuracy, but it's about, the liability. If, you're the doctor, you're the MD, and then you just, use this AI tools, and then something bad happened, we should take the responsibility. So you are taking the responsibility. That's why you want to make sure everything is working in the way that how the decision was made. And so this is also a big issue in some of the more high stack application. But also, in music, we also have a similar issue that, a lot of musicians are worrying about AI and, think that current AI has its limitation because, some of the agency, like the way, we write music because we want to express ourselves. And if AI is taking 90% of that, then what's the point of doing it? So, this discussion is also, linked to music making. Sam, how are you like anonymously leaning to that?
I kind of like the idea that not having to behave like a human, because it seems like if it does try to emulate acting like a human, it might not like be super accurate to like what the underlying process actually is. Like there's this one story of LLM agents like deleting a production database, and then when it was asked like, why they did that, it said that it freaked out. But we kind of understand that like it's not really like feeling emotion, and like it's not actually,
Yeah,
it's just some bug in like the code. That was like the most likely of was to act like a human and say that like it was a mistake.
yeah.
So I think like if the AI system were to actually think like a human, it would be nice for it to behave like a human. But if we prefer for it to think however is most efficient for the task, then it's okay to also not behave like a human.
Yeah, that's sort of the same as the iRobot. Have you watched iRobot? Yeah.
while ago.
A while ago, yeah, same. I mean, that's it's pretty interesting because the final, I mean, I don't want to spoil it, but it's also discussing about, AI is still actually following the rules and they make decision based on the rules, but that decision is not, following our, sort of like ethics, standards. And so that's very interesting in iRobot is that, well, at first people think that AI is broken, that against the rules that is ruining them, but they are actually trying to protect human by destroying part of human. I guess that's the point of the whole iRobot story. But that's sort of the discussion in iRobot. Sam? Okay, cool. Okay, we will check again at the end of the semester. Maybe you will change your mind. Yeah, because I guess the human like perspective, I'm not that critical on the, I mean, thinking versus acting. I don't really think AI has to know how to think, but human versus AI, I think sometimes human like machines has its own benefits. That's why people always talking about you know um if you think about AI not as just an agent, more like an assistant, the more human-like, the easier you can understand, it's working, or at least its thinking process should be more human-like, so that why they are making those decisions, rather than this is just a different set of rules that you need to learn. So I guess that's the other perspective of that. Cool. Anyway, I guess that's sort of wrap up our discussion on what is AI. So now we will jump into another term that's also an umbrella term that you might have heard of, machine learning. So I guess this is a sort of like a trying to disentangle some of the overlapping definition of AI, machine learning, and deep learning. And I think it's important because people always use them interchangeably, but it's not always the case. So AI is the one that started sort of like 1950s, when we sort of have like a better computer, but also some of the supercomputers being built. Supercomputer then, how big it is, considering that. So AI is basically, the easier definition in this context is, algorithm that just exhibit intelligence behaviors, like humans or not like humans, but, intelligence behaviors. And so for machine learning, it is a specific type of AI that shows intelligence through learning from data. And so this is the most of the AI service that we are thinking about nowadays. We sort of talk about big data, training data, and copyright infringement all the time. That's because some of the most advanced AI models nowadays are based on machine learning, and these machine learning are better in some of the tasks because they are actively learning from data rather than human defining rules, so that this AI can act more like human or to do things. And in the 2010s, that's when all the deep learning thing happened, and that's the latest AI wave. So these are algorithms that learn from data using deep neural networks. We will talk about what deep neural networks is later, but you can think of it as a specific type of machine learning that need more data and need a GPU, which is unavailable back then. So you need very huge capacity or capability to do parallel computing, and that's only available, sort of in 2010-ish. That's why nowadays you see a lot of deep learning, and people are racing for GPU. Now people always joke that we have a GPU wars. Now GPU is the money, the currency in this technology war. So what is machine learning? Well, I guess this is a better way to define machine learning. Machine learning is a field of study that gives computers the ability to learn without being explicitly programmed. So this is different from traditional programming and traditional AI. Like traditional AI is that human being intelligent, and then you try to write the rules and write a program so that these programs would act intelligent. But that's because you write the rules. But machine learning is different. Machine learning is trying to automate this process by letting the model um, learn to decide stuff, make decisions, to do things, to sense the world, or to take actions. Another more technical way to define it, we will see some examples so that you get to know why this is important, because it's very technical, but at the same time capture the core essence of machine learning. So we will use this for the next few slides to give you the sense what we actually mean by machine learning, why we need to define all these terms. So a computer program is said to learn from experience E with respect to some class of test T and performance measure P if its performance at testing T as measured by P improves with experience E. Like, take some time to digest it. So this basically captured the essence of machine learning. And as I said, deep learning is a subset, strict subset of deep machine learning. So even deep learning fall into this class. So we always need to think about, experience E. That's basically, the training data, the data we are learning from. That's very important because, without these data, we couldn't even, train or to make the machine learning better. Now, we need to define what we are trying to improve because, you are learning from something that you need a measurement to sort of know why you think this model is actually getting better. So you need to define what exactly this model is aiming for. So that's the test that we are talking about. And don't be confused by the word text. So this is the technical word. So music generation, source separation, even I don't know, improvisation. Sometimes in machine learning papers, we just call it a task. And it sounds like it sounds very unfortunate. It's like, a task, but it could be a huge task. It could be a very tiny, easy task. But most importantly, I think people always forgot about this, is that performance measure. You always need a measurement. You need a metrics to see whether you are improving so that you can know whether this machine learning algorithm is actually improving. And that also hint us about the challenge of machine learning to apply, in music and art, because oftentimes it's very hard to define the performance measure. Think about, music generation. What would be the measure? How do we measure this music is good? So, oftentimes people have to be, smart or I don't know, creative enough to think about surrogate performance measure so that these machine can learn from. So one of the good example about this is, think about ChatGPT. How does ChatGPT learn? We will get into it later. But how does ChatGPT learn? ChatGPT is not learning about the right answer for your questions because there is no way, you ask a random question. I don't know, like like a very random question you've asked ChatGPT that it couldn't possible to find answers online. Have you? I don't know what's I couldn't think about an example, but people always ask like random questions to ChatGPT. But think about that. It's like there's no way you can find a training data that actually tells you the exact answer to a specific question. So the way how ChatGPT is learning is just by learning what's the most likely word to follow the previous word. So you look at the sentence and it basically ChatGPT just look at what's the most likely next word to follow the previous one. So it will start it to sort of like learn the pattern through like local continuation about how to write a sentence and end the sentence. But over the time, when you train it more, ChatGPT will understand how to refer to some of the words that you ask in your questions and try to address those. So it doesn't necessarily learn from the exact answer to your question, but over the time from the training data, it's sort of like associate different concepts and then try to use those, distribution to make it sounds like a good answer. And, turns out it's a very good surrogate um, um, task for training these models. Cool. Oh, I have this slide. So, machine learning is different from traditional programs. So traditionally, you have some input and then you write an algorithm and then you get the outputs. So this is the way how we write most of our programs. And that's, why you take algorithm or, some of the C++ course and then you struggle on writing the algorithms. And over the time, you just learn to do it. But now, machine learning is different. That, whenever we are thinking about machine learning algorithm rather than machine learning model. So machine learning algorithm is different from machine learning model. Machine learning algorithms is about how do we do it this way. So we have some example inputs, example outputs, and we want to get a model. That's the machine learning model. So machine learning algorithm, when people are, some of these research paper, like, maybe you heard of, neural network, convolutional neural network, recurrent neural network, transformer, diffusion, what else? GAN, generative adversarial net, variation autoencoder, all sort of like, residual net, all sort of like these machine learning algorithm is for training the model. So you get a bunch of like example inputs and outputs. You want to learn how to map from that. And your output is a model rather than the traditional way. So, once you get this model, that's what we are usually using rather than, so these are for the research and development. So, if you are the company, you develop these machine learning algorithms, you train the model, and then you get the model. And as a user to these machine learning system, you are actually using a model like traditional algorithm. But by machine learning, we are actually talking about the training process, where we are interested in looking at different ways to learn about this mapping. Can we learn this algorithm and replace that with a machine learning model? Cool. So again, like we've defined it like improve on test T with respect to performance metric P based on experience E. So we would just have a bunch of example. So in this case, like animal classification, what would be a good performance metrics?
I think it's right.
Yeah, that's it. Yeah. So, percentage of correct predictions. For now, I mean, yeah, that's the obvious metrics. And what would be the experience E? And
Training the model.
yeah, but is that enough? It's just the photos. How do you know what animal is that?
Oh, the labels.
Yeah. So yeah, the experience E would be, I guess the easiest way is animal images with labels. There are some fancy machine learning model that could also, do it without labels, which we call like unsupervised learning and self-supervised learning. But this is the easiest way to define this task. Animal classification, you look at, whether the percentage of correct predictions improve over time, and how you learn from that, a bunch of animal images with labels. And, it seems like perfect, but actually, when you are doing deep learning or some of the machine learning models, you will realize this percentage of correct prediction is very hard to improve because it's something that's very hard to we call it like differentiable. So it's very hard to, make small improvements so that this percentage can go up. So that's why the whole deep learning thing is about. We will get into that later, but this is a way to think about machine learning model. So how about stock price prediction? What would be the performance metric?
Probably like the closest, like the distance from like the actual stock price.
Yeah. Any other ideas? I don't think so. I guess that's Easiest one. So this is actually what we call regression. So, this is classification. So we are doing classifying. So like sort of like sorting different images into different chunks. So, in music, think about source separation. You are grabbing a bunch of waveforms. You are grading, look at the spectrogram. And then, for each single bins, like this is like high frequency sound. This is like low frequency sound. Which instrument is that? So you are doing classification. But now what if, stock price prediction? Now we are, predicting a number rather than, a discrete class. You are predicting the continuous numbers. So this is what we call regression. And, later we will discuss how can you actually train a model that predict a real number rather than a class. So, the easiest way is to look at, the difference between the predicted and actual price. And, your goal is try to minimize that so that you could get a good stock price prediction. So what would be the experience? E?
I guess like just learning the training the model again on like stock price data.
Yeah, exactly.
Just the fact that like it sees the differences between its predicted and actual prices, and then you
Yeah.
change them on the point.
Yeah. So that's a good way to look at it. So I guess just historic stock price. So you can always do, pretending I am, in last year's point, and then look at all the historical price. Can I predict what I'm at now? And then you go to a different time point and try to see if you get a good sense of prediction. So, this is what lots of high frequency trading folks are doing, and they earn a lot. Quant folks, they are doing in Wall Street. I guess you can also guess what these two stock are. This is like September 2024, so it's a little bit outdated. Any idea related to this class? A hint? No idea. That's NVIDIA and Intel. So it's interesting because you look at the history. It's like IBM, and then once the big company of a computer, Microsoft, and then later on like Google with search engine, and now we have like NVIDIA. So you see the technology shift just by looking at the stock price. And NVIDIA is doing really good because of the GPU needs. So more music. So violin transcription. So transcription is a task that we refers to, listen to the audio. Can you get the scores? That's what we call transcription. Let me play it. So what would be the performance metrics?
The notes are correct.
Yeah, exactly. Yeah. And what would be the experience?
We want both like the audio playback as well as like the slush music.
Yeah, exactly. And that's also why this is very challenging, because oftentimes you don't get this. And so that's also one of the key challenge of doing music research, is that oftentimes it's very hard to get the experience, like the training data. The last one, beat tracking. This is something we will also talk about. So the technical definition is that, well, you just listen to the music and audio, and you want to predict where are the beats. So you can probably notice the slight difference in the tempo. There's some rubato. So, this is basically beat tracking, trying to mark where the beats are. So what would be the performance metrics?
It'd be like time differences, so it would like put them in like a row and then like compare like sequential?
Yeah. That's exactly how we do it. So typically you would just, have a spectrogram like the audio, and then look at all um the whole things, and you are basically marking the peaks of the dynamic, the amplitude, and most of the time they are pretty good, but sometimes they will be slightly off. But basically what you want to know is the time points where you have the beat and you have the ground truths where you can compare them with, and that's exactly the metrics and the target that you want to improve. So more technical, it's just average difference from actual timings, from your predict timings. And what would be the experience? I think it's really clear that just, a bunch of audios with all the beat timestamps. So I guess this sort of give it a little bit of sense about, how we should look at a machine learning model rather than, just thinking about beat tracking. Oftentimes, it could be easy to define a task. We want to do beat tracking. It's easy to define, we want to, just define this performance metrics. We want to get better on the timings, but oftentimes, you even know what you are experiencing, like the training data you need. But oftentimes that's the hardest part. There's no way, or there's very challenging ways to get some of these data. But to build a machine learning models, you need all of them. And you have to also think about how you can improve the performance metrics by looking at the experience. And that's what we will talk about in deep learning. Like deep neural networks is a way to actually improve the performance metrics by looking at the data. There's also the difference between, supervised and unsupervised learning. We will get into this. But basically for now, I guess, the way to look at it is, I guess, this comic do it really good. So supervised learning is just a class of machine learning model that, you are explicitly instructing the model whether, look at this Apple image and it says banana, then it's no. Then if it's doing the right prediction, then you say yes. So there are some feedback back to the model so that the model can improve over time. But for unsupervised learning, it's much harder. For the model, it's just like, well, looking at all the stuff that you have, try to, say, look at the similarity, look at the association, like look at the correlation between all these samples, and try to sort of like, well, group these three because they look alike, and group these three together, they look alike. And so, sometimes you can use like unsupervised learning to cluster them. And then later, once you have an example of just one single apple, then you can, mark all the cluster items into apple and all the other items into banana. So, in the past, people are mostly doing a lot of like supervised learning. I guess, still the same today. But especially in this age of like generative AI, we are talking a lot about unsupervised learning, or what we call self-supervised learning, where, these models are actually learning unsupervisedly. It's not like, like ChatGPT, we are telling them what's the exact answer to a specific question, but rather it's just like trying to learn the pattern, try to learn the distribution, try to continue what's being said from the input as your output and make it behave like a chatbot. So we will get into this more, but there's a not clear distinction, but there's two ends of the spectrum of supervised learning to unsupervised learning. And lastly, we will just talk a little bit about deep learning. We will get into more details later on. But once again, AI, ML, deep learning is like deep learning is a subset of machine learning. Machine learning is a subset of AI. So oftentimes people use them interchangeably, which is not quite accurate. So what is deep learning? Just a hint. So, a type of machine learning that use deep neural networks. So maybe perhaps you've seen some figure like this. This is just a very simplified way to look at neural network. And nowadays, none of the neural network look like this, but this is where people get started. So, you will have input layer, you will have output layer. So think about it, input layer could be, I don't know, say for animal classification, then you will have, I don't know, height, number of legs, does it swim, does it fly, things like that. And the output layer would be, whether it's a chicken or it's a fish or it's a dog. And all of these things in the middle, it's what we call hidden layers. And each of these layers, we call it a neuron. So these neuron not behaves, it's designed to be like our human neuron. And that's why we got the name of deep neural network. So, if you take a look on one of the single neuron, you will see that it's connected by several inputs. And that's also similar to how human neuron work. We will scratch the surface. We will get into it deeper later on. So, at the left is this artificial neuron. So several, blue things, some numbers, and then will merge into the red one. So what is being done inside this neuron is that you will have a bunch of numbers, x1 to xn, whatever, and you will sort of like do some calculation, weighted sum. You times it by a number, and then you add them up. And whatever that is, you will output something out. And at the right is the human neuron. So human neuron actually work, just understand, similar to these artificial neuron, or I should say it the other way. This artificial neuron is designed by, inspired by human neuron. So what it does is that, you have multiple inputs from the input side. So that's just like, in human neuron, you will get, each neuron is connected by all the other neurons, and they will send electric signals into the human neuron. And then you will end it up, add these signals up. And so in our human brain, we have this things called, threshold potential, is that when you have enough signals coming in, enough, I don't know, triggering things, or all the electrical signal together adds up to some threshold, then you will send what we call a threshold potential out to the next neuron that you're connecting with. So that's the same sort of like in artificial neuron. We actually have this threshold function. That's what we call sigmoid. But basically, you can think about it like a threshold function. We will get into this later, but this also sort of like trying to do that, if these inputs together add up to become larger than some value, then we will send something out as a 1. And if it's not, then send a 0. But, in deep learning, everything needs to be trainable. By trainable, we means like when we train a little bit in the inputs, the output should train also a little bit from the output, so that you can improve that over time. So we have to make it a smooth transition, rather than, everything below this threshold will be 0. Anything beyond that will be 1. So that's the difference between human neurons and artificial neurons. So for deep neural network, everything is soft. Nothing is like, well, this is a clear 1, shoot, or not. But for human neurons, it's more like a 1 and 0 things that, whenever you get all the electrical signals, if you bypass, you overcome the threshold, then you will shoot something out. So this is actually much more efficient. Anyway, even though, neural network is inspired by human neurons, nowadays, these neural networks don't really work like human brains. I guess that's the bigger things that we should keep in mind, that, we just use this name for some historical reason. Questions on this? We will get into it, but any questions so far? Sounds like magic. No. Anyway, we will get into it, and things will become much more complicated. But hopefully, I guess the reason why we are looking into some of the inner working of this model is not to be fooled by its behavior, so that you understand how things work. It's just like, why should we learn about FN synthesis? Why shouldn't we just use it? So one reason is that, if you knows it better, you have a better chance of using it correctly, or, misuse it correctly, or, enable new interesting ways to use it. But also, as a as a researcher, or if you want to challenge yourself, knowing the latest technology so that you can actually create new technology to enable some of the new interesting applications. So that's why we should look into some of the inner working of these. And also, to prevent us to be fooled by some of the, false claim of what these models can do. Cool. So that's just scratching the surface of what neural network is. We will have some deep learning 101, hopefully in 3 lectures, very challenging. We will get you the sense of what deep learning is without, taking the full semester long deep learning. So just give you the flavor, and we won't even, dig into the math and things like that. Just looking at what it is like, and what's the implication, and what's the intuition of some of the models that we know today. And so that you get a sense. Cool. But a step back, to look at without looking into details about deep neural network. One of the biggest difference between nowadays deep learning system versus traditional AI, I guess I usually look at it, a deep learning system in this way. Data cross model, cross use case. So usually we start from the use case. So, you have to know what you are trying to achieve. You want to know what's the task that you are doing. And then you think about the model. So usually the model is the easiest part. Unlike people always claim that, someone, have a new machine learning model, new deep learning model. And, oftentimes all these models are great. And it's much easier to get these models. But the biggest difference, from traditional machine learning is that the amount of data that's needed for training these deep learning models. So that's why people talk about big data all the time. And also, there's also a distinct difference between machine learning and nowadays AI is that only until very recently, because of the power of deep learning, that we can do things that we call generative AI. So traditionally, analytic AI is just this AI doing, learning from books or learning from training data and try to classify stuff and doing predictions, doing, recommendation, retrieval, search for stuff. But generative AI is a different thing that, it will generate some new stuff. It could be good, it could be bad, but at least, these models are now generating stuff. And that's why people are, sort of like worrying about it. But at the same time, there is also very interesting, powerful application of those. So that brings us to the first homework. But before that, it's a very fun homework. Hope you.
I am not Morgan Freeman, and what you see is not real. Well, at least in contemporary terms, it is not. What if I were to tell you that I am not even a human being? Would you believe me? What is your perception of reality? Is it the ability to capture, process, and make sense of the information our senses receive? If you can see, hear, taste, or smell something, does that make it real? Or is it simply the ability to feel? I would like to welcome you to the era of synthetic reality. Now, what do you see?
So, as he said, this is not Morgan Freeman.
I am.
Nope. Let me click this.
I am not Morgan Freeman, and what you see is not real. Well, at least in contemporary terms, it is not. What if I were to tell you that I am not even a human being? Would you believe me? What is your perception of reality? Is it the ability to capture, process, and make sense of the information our senses receive? If you can see, hear, taste, or smell something, does that make it real? Or is it simply the ability to feel? I would like to welcome you to the era of synthetic reality. Now, what do you see?
Cool. So that's what we'll be doing in homework one. But before that, I guess also, you've likely seen some of these generative AI for visual arts. So this is like the first, yeah, it says so. Be the world's first AI generated magazine cover for Cosmopolitan. And this is another, this is famous. Have you seen this? Nope. Okay, so I'm so biased towards AI news. So this was Colorado art fair, and so someone made this and then sent it to that art fair, and they actually won the first prize in digital arts. I think they finally retrack it, but that's sort of give you the sense, how it becomes so controversial, but at the same time also showcase, some of these AI technology are getting there into something that, well, it does do something interesting that people find some value in it, but at the same time, how do we think about authorship and how do we think about where's the creative intention of artists? How do we rethink about the process of art? So, some of these visual arts are getting, Gen AI for visual arts are getting there. And this is also another case in MoMA, where they are having this very cool installation where it's like generative art. There's a video in the link, but you can take a look. It's like these things will move. I should have put a video rather than a still static image. So the last one is also AI generated photograph. So it actually also won the Sony World Photography Award in Creative Open category. I don't know whether they retract it. I know this one is retracted, but for that one, I think the author, the artist themselves, the photographer just retracted themselves. But I think his message to this is that, well, now these AI generated image is too good, and sometimes you can even want some of the award, and it's just a very interesting discussion. And also, you likely also seen this, Sora by OpenAI. I think now it's even better. And also, Google recently released Veil, and Meta also released Movie Gen. So some of these video generation models are also getting better and better. Anyway, so that's our first homework. Should be pretty fun. We were just looking at a bunch of images, and you want to see whether they are real or fake. And likely, as I did, you will be surprised how we can get fooled by some of these. So, other than just images, there will also be some, speech recording, but also
The objective of the nation has greatly changed in 3 years.
Show up and vote. You will determine the outcome of this election. Vote, vote, vote. If you're able to vote early in your state, vote early. If you're able to vote in person, vote in person. Vote whatever way is the best way for you.
it's broken.
We meet at a college noted for knowledge, in a city noted for progress, in a state noted for strength.
Yeah, anyway, you're just looking at a bunch of those. I've already posted on the website, so there's a bunch. And also, don't worry about it. You will be graded by completion instead of correcting yourself, of course. So have fun. I mean, it's pretty interesting. For me, I mean, I don't think I get it correct. I mean, looking at these, I know some of these images are fake, but I couldn't tell right now, especially for the human faces. It's very hard. And so you'll get a sense. I mean, some of those are real, some of those are fake. Quick recap. We talk about what AI is, how fast it changed, the definition change over time, human-like versus not human-like, and Turing test, AI versus machine learning versus deep learning, machine learning. And we talk about this thing, about the definition, and we talk about deep learning and artificial intelligence, and of course, homework one. So next class, we will talk about AI music. So more about, how AI and music has been together over the time for decades. Cool. Yeah. Next Monday is off, right?
Yeah.
Oh, okay, cool. See you next Wednesday.